Alright, we move on to question 2, alright, which shows the tanker that starts its motion from rest and travels in a straight line. Okay, the mass of the tanker is given, the force acting forwards on the tanker is given as well here. Alright, and the acceleration of the tanker is not constant. Alright, at what instant drag force acting backwards on the tanker due to water is this amount? Calculate the acceleration of the tanker. Right, in this kind of questions, when we approach acceleration questions, alright, generally you can have two ways to go about it. One is we approach by F net equal ma, which is what we are doing here. The other way to get acceleration is by v minus u over t. Alright, clearly in this case we go for the F net equal ma approach because there's no hint of velocity, alright, as well as time given in the question, alright, and instead you are given mass, alright, as well as forces, right? So F equal ma is likely to be the correct approach, alright. So with that being said, alright, since we know we are using F net equal ma, alright, we should know that we should actually draw a free body diagram whenever we use F net equal ma. Alright, so a good student would probably draw free body diagrams to represent the constant forward force, right, as given in the question, right, as well as the drag force, right, as given in the question here, right. So there are two forces, the constant forward force, which is this one, and the drag force, which is this one. Right, so the net force, right, which equals to forward force minus backward force, right, or the drag force, alright, is given here. So constant forward force minus the drag force equals to mass times acceleration. Okay, you find mass, you find acceleration finally, and remember that acceleration is 203 SF. Okay, so remember that. Okay, so yep, so important note, if you are using F net equal ma, you draw free body diagram. Okay, explain in terms of forces acting while the acceleration is not a constant value. Alright, again, when we look at this type of questions, which are very common in O levels, right, in terms of forces acting means look at the free body diagram. Right, so luckily we have already drawn the free body diagram earlier. Right, this force is a constant. This force should actually change with respect to velocity if you had studied your resistive forces part of your textbook. Alright, so the answer is when there is acceleration, the velocity increases, right? So because velocity increases, the drag force increases, right? This statement over here should be 1 mark, alright? And as drag force increases, the net force reduces. Why? Because if you look at this equation, forward force is constant, drag force increases, the total value of F net should drop, right? So once F net drop, with mass remaining constant, acceleration should be decreasing, alright? So if you really want to be very specific, you could add those things that I said, like mass is constant, therefore acceleration decreases, right, and drag force is increase with the constant forward force staying the same, the net force reduces. Right, so there will be a very specific answer. Okay, but as I have it, I think these are the key points that will give you 1 mark. Right, we move on to part C. Okay, engine stops at time t equals 60 minutes. Alright, velocity decreases. Alright, next 40 minutes, the tanker travels a distance of 12 kilometers. At the end of the 40 minutes, the velocity of the tanker is 0. Sketch a graph to show displacement of the tanker with time from 60 to 110. Right, so at 60 minutes, this is where the engine stops. There's no more forward force. Okay, so because we are drawing a displacement time graph, which is quite rare but definitely within the syllabus, alright, we need to pay attention to how to express the fact that velocity of the tanker then decreases. Alright, so how does velocity decrease gets expressed in a displacement time graph? You should know that displacement time graphs gradient is velocity, and therefore velocity decreases means that the gradient of the graph decreases. Right, so in the next 40 minutes, where the tanker still travels a distance of 12 kilometers, means that somehow from 0, right, I'll travel towards the forward distance to 12, which means I end up somewhere here. Right, so from here to here. Alright, and the shape should represent velocity decreasing, which means the gradient should be dropping. Alright, then after that, it should be a horizontal line because velocity is 0, which means displacement is a constant. Alright, so I'll straight away give you the answer over here. Right, so I know I start from here and end at 12. Right, the shape of the graph should express that velocity is decreasing. How? By having the gradient decreasing. Alright, and finally we have a horizontal line here to represent that the tanker has stopped. Alright, so these are marking points. Stick to 0 gradient. Alright, somewhere around here is 0 gradient lah. This part should be smooth, but I think something like that is perfectly acceptable as well. Okay, and of course the second mark will be horizontal line at this point. Alright, and part 2, state how your graph shows velocity of tanker decreases. We've already discussed this, so I'll go straight to the answer that the gradient of the graph decreases. Alright, that's how we show that velocity of the tanker decreases.